Welcome back to the course Geotechnical Engineering. So this is we are in the module 1, which we are discussing about the soil formations. So in the previous classes we are discussing about what is the definition. We are discussed about what is meant by the rock and the formation process. We have seen already about the rock formation process of the rock, and then types of rocks. We discussed it, like igneous, sedimentary, metamorphic are the three basic types of the rocks, and there are subtypes which comes under few of them, like basalt, gabbro comes under the igneous, and other type of rocks are also there, like marble, which comes under metamorphic rock. So then after from the rock fragments, then we have discussed the process for the formation of the soil, like weathering and types of weathering we have seen, and the continuation to the previous lecture. The topic of today lecture is about the soil formation, and after that then we will see the few structures, once after forming the soil, then what are the various structures, how we will identify those structures, and also the basic soil volume relationships also we will see in this lecture. So coming to this residual and as well as transported soils. So as we discussed in the previous class, whenever the newly formed soil deposit, which is very near to the parent rock, that we referred as a residual deposit, and if it is away from the parent rock, the newly deposit, if it is away from the parent rock, that we referred as a residual transported deposit. So here you can see the examples right side of this slide for residual and as well as the transported soils. Like, see, the water is very here the water is one of the agent which is from a alluvial type of soil. So then soil which are formed by weathering of rocks maybe remains the position at the same place of origin. So in this case we will call it as a residual. It maybe remains the parent rock position. The newly deposit may occupy the parent rock position, or it may move, but not that much long. So very near to that parent rock. So that type of soil deposits we referred as residual soils. And then the other cases, these may get transported. So the newly deposit, if you say this is a newly deposit, this is a parent rock, and this is the parent rock, and after weathering, some maybe residual what is meant by the residual soil is nothing but the newly formed deposit may occupy the parent rock position, like it in this, or maybe somewhere here, like that. So whenever, if it is transported, if this deposit is transported through any one of the transporting agent, so in that case another deposit will form. So with respect to the parent rock, compared to this earlier formed deposit, this is far away to the parent rock. So in this case we will call it as a transported deposit. So here soil which are formed by weathering of rocks may remains in position at the place of origin. In that case it is referred as a residual soil. And another case, these may get transported. So here they mention like transported. The transporting agents are different, that we will see in the coming slide. So these may get transported. Which one? The residual deposit, or other parent rock. These may get transported from the place of origin by various agencies. So which various agencies, such as wind, water, gravity, and ice. So these are the various agents which these are responsible for the transporting of that particular deposit, and then again it will occupy some new position. So that entire this phenomena, the soil which is formed from this phenomenon, we call it as a transported soils. And the residual soils differ very much from the transported soil in their characteristic and as well as engineering behavior. So here the residual soils are these transporting agents are not responsible for the formation of the residual soil. Only due to the weathering, and the residual soil will occupy certain position, and when transporting agents are acting on that particular deposit, again the deposit change its position. then the new position it will occupy. And during that time, the engineering properties of that particular soil particles, and as well as the other characteristics of those, like in case the chemical characteristics also may get changed, because if it is through chemical mechanical weathering and chemical weathering are the two types. So these agents are comes under responsible comes under the mechanical weathering only. So in that case, the residual soil will not much differ from the transported soil in case of characteristics and as well as the engineering behavior. So now the transported soils may be further subdivided into the transported deposits, which are formed through some external agent. So then the transported soils may be differed, may be further subdivided depending upon the transporting agency and as well as place of the deposition. So here, these are the various type of soils for the formation of these soils, like alluvial, aeolian, glacial, and lacustrine and as well as marine soil. So there are few transporting agents, like as we discussed in the last slide, like wind, gravity, and as well as glacial, ice are the transporting different agents. So this is alluvial type of soil. The soil transported, this type of soil is transported by the river and as well as streams. So here the river water is the transporting agent. The river water is a transporting agent. So then the aeolian is another type of soil. The transporting agent for the formation of this type of soil is wind. So last is the example for this type of soil, aeolian. So then glacial soil type. So the transporting agent for this glacial is ice. Glacial is ice, and drift and as well as the till are the very good example for this type of soil types. Okay, and lacustrine is another type of soil. The transporting agent for the formation of this lacustrine is lake water, lacustrine silt, and as well as lacustrine clay are mainly formed due to this process. So marine soil deposits that we can see at the seabeds, and the seawater is responsible for the formation of this marine type of soil. So the broad classification of the soils are maybe like coarse grained soils and as well as fine grained soils. So where coarse grained soils are nothing but the average grain size greater than the, if the average grain size of the particle, like if you say if it may be any shape, like it may be in different shape. The average grain size of the particles of that particle greater than 0.075 mm. So in that case, we will call them as a coarse grained soil. The example of these coarse grained soils are gravel and as well as the sand. Gravel and sand. The average here, the average grain size of this particle is how much it is? It is greater than 0.075 mm. So whereas fine aggregates, fine grained soils is which are less than the 0.075 mm in size, less than the 0.075 mm in size. The examples of this one is silt and as well as clay. So these are the two various type of soils, gravel, sand, silt and clay, as we discussed about this in the previous lecture. So the example of these coarse grained soils is gravel and sand, and the example for the fine grained soil is silt and clay. So some commonly used soil designations are, you will see. So like these are the various fine aggregates and as well as coarse aggregates. These are the common names we usually use in our day-to-day life. So the bentonite is another type, and the block cotton soil comes under the clay, and it is boulders clay. Like compared to this particle, the boulder clay is somewhat bigger in size, but less than 0.075. And these are other hard pan and laterite. Loam is a combination of the silt, clay and as well as sand. So loam is a combination of this silt, clay and as well as sand. And also is another type of soil, and moram, topsoil, varied soil. So these are the various commonly used soil types. So another major important topic is structure of the soils. As of now, we discussed the soil formation and what are the various agents are responsible for the formation of each type, like alluvial, marine, and aeronautical. So then after whether it is maybe a residual or it may be a sedimentary. So some deposit, we as of now we pronounced that it is some deposit. So then in this one there may be a coarse aggregates are present, there may be a fine aggregates are present, and there may be a water content is also present. Like so there are different things are present. So then by seeing only those departments, those deposit, how we will identifying them. So like how we are identifying them. For example, if you take here it is some newly deposit which is formed to some weathering process. This is a newly deposit. Here some coarse aggregates, fine aggregates, like coarse aggregate, and as well as fine aggregates, and then the water is also present in this. So like the water is also present in this, and as usual air always will be always there. So now in order to identify the type of structure, we must to know that each classification of the structure, and then what are the basic what are the basic characteristics to identify that type of structure. So coming to the type of structures, you see the structure is nothing but it is a geometrical arrangement of the soil particle in soil mass. Okay, so the behavior of the soil depends upon the soil structure. So it is actually the soil structure is actually a geometrical arrangement. The soil structure is actually geometrical arrangement. Okay, so here this the structure behavior is depending upon their arrangement. So if you talk about in detail about these structures, so if the first one is the soil's type of structures. So the structures are single graded structure, okay, honeycomb structure, folliculated structure, and dispersed and as well as composite structure. So there are totally 5 structures. In some textbooks you can see only up to 4, and the single graded, honeycomb, folliculated, and as well as dispersed structure, and then the other one is composite structure. So single graded structure, actually it is an example for the gravel and as well as sand, though the present in the coarse grained soil only. So as we discussed, like this is a type of structure maybe. So here the present in this single graded structure is present in coarse grained soil such as gravel and sand, and it is formed due to the settlement of soil particles under gravitational force. So it is one of the transporting agent, gravitational force. Colluvial soil will type of soil, the colluvial type of soil will form from this gravitational force, and the single graded structures, whatever the coarse aggregates are, example we consider for this single graded structure, and these are formed due to the gravitational forces. So gravitational forces. So then depending upon their geometrical arrangement, it may be a loose in state and as well as dense in state. Okay, so there here we can see it is very much dense in the state. Dense and loose is nothing but the pore space between the particle to particle in case of dense is very minimum, whereas in this case you see that geometrical arrangement of the particle in case of loose state, the pore space between the particle to particle is very high compared to A. Another technical word is it is wide ratio, that we will see what is the wide ratio of this dense state and as well as a loose state. Okay, so if the particles are assumed, if the particles are assumed as a sphere, the loosest and as well as densest packing are shown in this figures. So it is the loosest state of the geometrical arrangement, whereas the densest state kind of the geometrical arrangement of this single graded structure. When the particles are assumed as perfect sphere, the wide ratio of that kind of soil, like which are we assumed as a perfect sphere, in that case the wide ratio of those in loosest state is 0.91. It is in 0.91, whereas the in densest state the perfect sphere particles wide ratio is 0.35. So it actually refers the pore space between the particle to particle. In case of if it is perfect sphere particles, then in that case the wide ratio in case of loosest state is 0.91, whereas the wide ratio in case of dense state is 0.35. So coming to the honeycomb structure. So this is another structure. So in this it actually present in fine and as well as fine sand and as well as silts. fine and silt type of soil. So the honeycomb structure actually supports a load only under static condition. It actually supports a load under static condition. So then if you want to break this honeycomb structure, it actually required a lot of force and as well as some type of load like a shock load. So the under vibration and as well as the shocks, the structure collapse and the large deformation take place. So in order to if you want to break this honeycomb structure, it is required some vibration type of loads and as well as sudden shock loads like impact loads. Okay, so then the honeycomb structure particle to particle contact is very close like this. You can see honeycomb structure like this. The structure of the honeycomb is like this. It is refers actually this figure is refers to single graded structure, whereas this one is refers to what? Honeycomb structure. So it is like a the particles are like connecting like this. Okay, so the example for this honeycomb structure is sand and as well as the silt. So other one is falculated structure. So the falculated structure example is clay, and this occurs in clay soils, and while doing the process it will edge to face orientation, and the clay particles have large surface area, and therefore the electrical force are important in such soils. So the surface area compared to any other, it occupies large surface area. Simply we can call it as SSA, specific surface area, whereas the clay particles have a negative charge on the surface and the positive charge on the edges. So when it is the process the orientation of this falculated structure is edge to face, and at the edges it is in negative charge, and whereas the surface is positive charges on the edges and negative at the surface. Okay, the interparticle connect develop between the positively charges, and these results leads to formation of the falculated type of structure. So continuation to the falculated structure, the degree of falculations of clay depends upon the presence of the salt particle. So the degree of falculation of clay is depends upon the presence of salt content or salt particles in the clay type of soil. So the salt water acts as an electrolyte and reduces the repulsive forces between the particles. So there is two different type of forces like attractive forces and as well as the repulsive forces. And due to the presence of this salt water in this type of soil, this actually reduces the repulsive forces, and due to the attractive forces are the responsible for the formation of this type of falculated structure. So the clay settling out in a salt water solution have more falculent structure than the clay settling in the fresh water. Okay, because where due to the presence of this salt water, the repulsive force is reduced. Okay, have high shear strength. These falculated structures have high shear strength, low compressibility, and as well as high permeability. So where this shear strength, compressibility, and as well as permeability actually engineering properties of soil. Engineering properties of soil is nothing but permeability, shear strength, and as well as compressibility. Again, in compressibility there are two: compaction. Compressibility types is compaction and as well as consolidation. So the falculated structure is basically very high in shear strength, low in compressibility, and very high in permeability. Okay, the another structure name is called dispersed structure. So this dispersed structure is due to the concentration of the dissolved minerals in water. It occurs in remolded clay, whereas the particles have face-to-face contact. Previously it is edge-to-face. So in this case of dispersed structure, the particles orientation is face-to-face, and then less specific surface area, and the formed when there is a net repulsive forces between the particle. So whereas in the case of falculated structure, it is due to the attractive forces. In this case, it is formed due to the net repulsive forces between the particles. And this dispersed structure is have low shear strength, and have high compressibility and low permeability. So just vice versa to the falculated structure, whereas in case of falculated structure, shear strength is high, and in this case of dispersed structure, it is low. So in the previous case, compressibility is very low, and in the dispersed structure, compressibility is very high. So coming to the permeability, in case of falculated structure, the permeability is very high, and in dispersed structure, the permeability is low. Another important point to be remembered in this case, the formation of the dispersed structure, the attractive forces, the net repulsive forces are responsible, whereas the formation of this falculated structure, the attractive forces are the prime responsible. Okay, so those points to be remembered. And the another one is composite structure. So the composite structure, it is formed when the soil contains a different type of particles. It is not very particularly gravel type, sand type, or clay or silt. So it is a combination of different type of particles. As we can see, the skeleton of this composite structure, coarse grained and as well as clay matrix. So you can observe here the maximum in this right side figure, the maximum content deposit is occupied by the very fine particles. As you can see, the small particles, and the clay matrix structure we call it as, and the other one is where you can see the minimum clay particle and the maximum coarse grained particles. Here it is coarse grained skeleton. So this is a combination of the coarse and as well as fine aggregate, and we will call it as a composite structure. So as usually in this case, the water and as well as air is always present. So that is the other topic that we will see in the soil volume relationships. Okay, as I told, coarse grained skeleton. So there you can see the formed when the bulky cohesive particles is large compared with that of the fine grained. As you can see in this figure only, it is easily to understand. There are many coarse grained soils and as well as compared to the fine aggregates in this case. Okay, and the other one is clay matrix structure. As in this case, the formed when the amount of clay particles is very large. Amount of clay particles are very large as compared with the bulky coarse particles. So you can see the amount of clay particles. See, maximum portion of this deposit is occupied by the fine particles, whereas here the fine particles are very less and coarse particles are comparatively high. Okay, another one is texture of the soil. So as of now, we discussed the type of soil structures and the types for each soil structure. Coming to the texture, the term texture actually refers to the appearance of the surface of a material. So such as fabric. So it is used to similar sense with regard to the soil. The texture actually used exclusively to sense the soil sense the soil. The texture of the soil is reflected largely by the particle size, shape, and as well as the gradation. So some major type of the soil deposits across the India we will see. So the black cotton soil, nothing but clay. So the black cotton soils occurring in Maharashtra, as you can see, Maharashtra, Gujarat, and as well as Madhya Pradesh, Karnataka, and some parts of the Andhra Pradesh and Tamil Nadu too. So these are the major areas which are covered by the black cotton soils, and these are expensive in nature. The black cotton soils are very expensive. Expensive in nature. Like they may shrink in dry season. They may swell in rainy season. So, on account of high swelling and as well as shrinkage, the potential of these are difficult soil to deal with the foundation design. So, because of this expansive nature, to deal especially in the foundation point of view, it is very difficult to deal with these black cotton soils. So, another marine deposits. These are, we can see along the coastal areas, especially in the Rana of Kutch division, which is in Gujarat. And these are very fine, very soft, and as well as sometimes contain organic matter, possess low strength and as well as high compressibility. Low strength and as well as the high compressibility. So maximum coastal regions of India covered by this marine soil. So another one is desert soil occurring in Rajasthan, and alluvial is occurring in the Indo-Gangetic plain north of the Vindhyachala ranges. And because there are many rivers, so alluvial type of soil will be formed. Okay, the laterite soil is a type. Another one which is you can see in Kerala and as well as the South Maharashtra, including the Karnataka and as well as Orissa, West Bengal. So these are the various soil deposits that occur all over the India. As we can see the soil map of the India, major portion of this soil map of India, as you can see, the alluvial complete northeast, you can see there are very big rivers over this area. As you can see, this is completely alluvial deposit. Okay, and coming to the Rajasthan area, it is like a desert. Okay, desert is a type of soil, and this is hard rock and as well as red soils. Red soils complete this near south region, peninsular region, and the part of the peninsular region in the, coming to Maharashtra and Madhya Pradesh is soil type is black like this. Okay, so these are the way. This is the soil distribution over the India. The major types is black cotton, marine, desert, alluvial, and as well as lateristic soils. And some compositions of soil, which includes terminology and definitions, we will see. The compositions of soils are like soil is a complex in physical system. As like we discussed, it is a combination of the composite structure. There are maybe a coarse aggregate and as well as fine aggregates are present. A mass of soil includes accumulated solid particles or soil grains and the void space that exists between the particle. And the void space may be a partially or completely filled with the water. The void space may be a partially or completely filled with the water and some other liquids. Okay, so the void space is nothing but like if it is a soil grain, so the gap between this the gap between okay, no, the gap between this is a white space, and this white space may be occupied by this water and as well as some other liquids. So okay, so the white space not occupied by water and any other liquid are filled with the air and some other gases. So if it is not filled with the air and other gases, it is not filled with the water and other liquid. It is obviously occupied with the air and as well as some other gases. The phase means the phase means any homogeneous part of the system. So like so where phase means any homogeneous part of the system from the soil frame, which we'll see. Different from the system, the phase is different from the other parts of the system and separated by they may some transportation. Here you can see, as of now we discussed about these systems. Phase, where phase is not but some homogeneous separated from the other. As you can see, this complete phase is air and the another complete phase is water, and in this case solid particles. So here fine and as well as coarse may be present. So the soil mass exists in nature. It is more or less random accumulation of the particle like a composite structure. So water, this during that random accumulation, the soil particles, water and air filled spaces are also we can observe. As you can see here, the water around the particles and filling up irregular spaces between the soil grains. And whereas here soil grains, these are the soil grains, and in this case fine and as well as coarse may be present. And the other one where the water is not covered, that portion is covered by this air and as well as some other gases. Air and some other gases. Okay. So since the volume is occupied by the soil, soil mass may generally be expected to include material in all the three states of the matter. So those are like solid, liquid and as well as gases. Okay, so entire this system be referred as what? Three-phase system. So when in this three-phase system, when the soil voids are completely filled with the water, the gaseous space being absent, so then in that case it become only two-phase system. So now it is three-phase system. In the previous case it is a three-phase system. So in this case, air, water and as well as soil, three are present in this case. Whereas two-phase system only two phases. Suppose for example, in case of gases is absent completely, the entire portion is filled with the water. This is called, we simply called as a saturated soil. So this is, we call it as a saturated soil. In the other case, when there is a water phase is absent but only air is present, in this case we call it as a dry soil. We call it as a dry soil. See, when the soil voids are completely filled with the water, the gaseous phase is being absent, it is said to be a fully saturated. Nothing but S is nothing but degree of saturation. In this case, in case of fully saturated, the S is equal to 100%. Whereas the other case we see, when there is no water, when there is no water at all in the voids will be filled by air, and the liquid phase is being absent, thus is said to be a dry. So in this case, it is a dry, and then here S is equal to 0. Whereas in case of fully saturated condition, the S is equal to 100%. So if you see some basic terminology, this is the three-phase diagram we considered to derive few formulas from this. The three-phase diagram consists of air, water, and as well as soil grains, and the number of quantities or ratios are defined below. Like we will discuss from this three-phase diagram only, like void ratio, porosity, and there are other associated formulas with the void ratio and porosity. Also, we will discuss. We will see from this, and which constitute the basic terminology in soil mechanics. The use of these quantities in predicting the engineering behavior. Actually, this whatever the various parameters definitions we have determined from this, we can use to predict the engineering properties and other index properties of this soil. Okay, so the three-phase diagram we will see in this, as we know, air is one phase and the water and the soil grains is present, where the entire three-phase diagram we represented with a V. V is a volume of soils, complete phases, and the volume of voids is equal to, you can see, where volume of air is equal to VA is equal to nothing but volume of air, and VW is nothing but volume of water, and as well as VS is nothing but what? Volume of soil. And here combinedly volume of voids is nothing but volume of air plus volume of water. So combinedly volume of voids is nothing but volume of air plus volume of water, and the total volume is equal to volume of air plus volume of water plus volume of soil. Volume of air plus volume of water plus volume of soil. As if you take this case like two-phase system, in this case, if in case air is absent, so this become dry, this become fully saturated. In that case, volume of voids is equal to only volume of water. So actually, the volume of voids is equal to volume of air plus volume of water. Suppose if S is equal to 0, like the first case 1, if S is equal to 0, nothing but this volume of voids is become what? S is equal to 0. This volume of voids is nothing but volume of air only. And in case the case 2, S is equal to 100%, where S is nothing but degree of saturation. So S is equal to 100%. Again, this volume of voids is equal to volume of water, and the total volume is equal to volume of voids plus volume of soil. And the volume of soil is equal to volume of water in case of degree of saturation 100%, and then it is equal to volume of soil. So this is the three-phase system of this. Okay, coming to the summary of this today lecture, we discussed about the various transported and as well as residual soil deposits. First topic, and the other one is as we discussed various transporting agents and type of soil. Then the other one which we discussed about the soil structures. So like single graded structure, honeycomb structure, falculated, and as well as dispersal structure. So the example for the single graded structure is gravel and sand. The example for the honeycomb structure is sand and silt, and the example for the clay is example for falculated structure, and the remolded clay is example for the dispersed structure. So then immediately after this we discussed about the three-phase system of the soil. Three-phase system of soil, like air, water, and as well as soil. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.